In this video, we're going to talk about inverse functions. Before we can define an inverse function, we do have to define one property of a function first, and that is whether or not a function is one-to-one. So we say that a function f is called one-to-one if it never takes on the same value twice. That is, if f of x1 is not equal to x2 whenever x1 is not equal to x2. This means that two x values cannot have the same y value. Graphically, we know that a function is one-to-one if and only if no horizontal line intersects its graph more than once. Now that we've defined a one-to-one function, we can define a function's inverse. A function does not have an inverse unless it is one-to-one, and that's why it was key for us to define that previously. So if f is a one-to-one function with domain A and range B, then its inverse function, depicted here, has domain B and range A and is defined by the following. F inverse of y equals x if and only if f of x equals y for any y in B. So with a function and its inverse, the domain and range are switched as well as the specific points. So the input x in the original function will be the output of the inverse, and the output of the original function will be the input in the inverse function. Here's how to find the inverse function. First, write y equals f of x. This just means that if your function is given as f of x, use the notation y instead. Next, you'll want to solve this equation algebraically for x in terms of y. This means that you'll want x by itself on the left-hand side, and on the right-hand side an expression containing only y's. Finally, to express f inverse as a function of x, interchange x and y. The resulting equation is the inverse f inverse x. Now let's do an example. We want to find the inverse function of f of x equals 2x plus 3 over x minus 1. So step one is to write y equals f of x. So I'm going to write this as y equals 2x plus 3 over x minus 1. Now I want to solve this for x in terms of y. So the first step that I'm going to do is get rid of this fraction here. I'm going to multiply the entire equation by the denominator, x minus 1. On the left-hand side, that gives me y times x minus 1. And remember to keep that in parentheses because you want y to multiply that whole thing. And then on the right-hand side, those cancel out, and I'm left with 2x plus 3. Next step is I'm going to do the distributive property on the left-hand side. I'm going to distribute the y, so that gives me xy minus y times 1 is just y. Next, we want to put the x terms on the left-hand side. So I'm going to subtract the 2x from both sides and take it over to the right. That gives me xy minus y minus 2x equal 3. Now I want to take the non-x terms and take them over to the right-hand side. So anything without an x needs to go over to the right. That means I'm going to add y to both sides. So I have xy minus 2x equals y plus 3. Next step, I'm going to factor an x from both terms on the left-hand side here. So that gives me x times y minus 2 equals y plus 3. And finally, divide both sides by y minus 2. So I have x equals y plus 3 over y minus 2. So now step 2 of the process to find the inverse is done. The last step is to just interchange x and y. So my final answer will be f inverse of x equals whatever I have on the right-hand side here, except just replace the y's with x's. So that is x plus 3 over x minus 2.